children. Welcome to your Maths class. Chapter 3, Algebra. In today's session, you are going to learn about algebra. First, let us see what are the learning objectives in this chapter. The first one, to express the numbers in the exponential form. You are going to learn about exponential form. To understand the laws of exponents. To find the unit digit of numbers represented in exponential form. And to know about the degree of expressions. So these are the learning objectives in this topic. Okay. Now let us move on to the exponents and power. Let us see what is mean by exponent and what is mean by the powers. Okay. So if a is any integer, then a into a into a, it goes on a, that is n number of time. That can be expressed as a power of n. Here a is the base, okay, the where the place the a present, that is called as a base, and n is called as a exponent, or it is called as a power, okay. Now this method of expressing a number is called exponential form. Have you all understood, children? So like this, in this method, when we are expressing a number, that is called as an expression form. Sorry children, exponential form. Let us see some example based on this. 16. 16 can be expressed as 2 into 2 into 2 into 2. So how many 2's are there? 4. So you can express this as 2 power of 4. That is, the base is 2 and the power, the 4 is expressed as exponential, or it is called as a power. Okay, so it can be read as 2 raised to the power 4 or 2 to the power of 4 or 2 power 4. Here 2 is the base and 4 is the exponent. That I have explained to you. Have you all understood, children? So you can read this as 2 raised to the power 4 or 2 to the power 4 or 2 power 4. You can express in any way. Okay. Now the exponent is usually written at the top right corner of the base and smaller in size when compared to the base. I think you can understand. So 2 to the power of 4. The power 4 is expressed to the, that is the exponent. It is expressed to the a small size and the right corner of the base. Which is the base number here? 2 is the base number and the 4 is the power. Okay, so you can express it like that. Do you understand, children? Okay, now let us move on to the next one. When a number is expressed as a product of factor and when the factors are repeated, then it can be expressed in the exponential form. I think you understood already. I told you an example. 16, that is 2 into 2 into 2 into 2, 4 times 2 you will get. That is the factors, and it can be expressed as 2 power of 4. Okay. So the repeater factor will the base and the number of times the factor repeats will be its exponents. Okay. For example, if you take 64, 4 into 4 into 4, that can be written as 4 cube. Okay. So that's what. Now let us see the numbers in the exponential form. So this already I taught you a. Only 1 is there. So a to the power 1 you can write. A into A, that can be raised as A square. A into A, that means A power of 3. So n number of time means A power of n. So then we can generalize the exponential form as A power of n, where the exponent is a positive integer. Okay. Now let us see some example based on that. See 100. So 100 can be written as 10 into 10, that is 100 square. This can be expressed as the product of two different bases. What is the meaning of product, children? Multiplication. With the same exponent as 100, 100 can be read as what? 25 into 4. 25 4s are also 100 only. Now here the 25 can be expressed as 5 into 5 because 5 5s are 25. And 4 can be expressed as 2 into 2. That is 2 2s are 4. So you can write in the exponential form that 5 into 5. How many 5 are there? 2 5. How many 2 are there? 2 2. So you can write 5 square 2 square. Do you understand, children? So we notice that 5 and 2 are the base and 2 is the exponent, that is the power exponent, or it is called as a power. So in the same way, A into A into A into B into B. So A can be how many times? 3 times. So A cube you can write, and B can be expressed as B square, that is B to the power 2. Consider 35. That is 7 5s are 35. So 7 one time only you will get and 5 also one time, where there is no repetition of a factor. So in this number there is no repetition, that is the number won't be get repeated. Only 7 5s are. So 7 to the power of 1 and 5 to the power of 1. So it can be represented as 7 into 5. Okay, so when the power is 1, the exponent will be in explicit mentioned. It is like only it is in the 1. It is explicitly mentioned as power of 1. Okay, now let us see some more summaries based on this chapter. Let us recollect everything. If a is an any integer that I already explained to you, a power of n, that is the a is the base and n is the exponent power or the index. Minus 1 power of n. So minus 1, if it is the even number, that is for example minus 1 the whole square, means you will be getting minus 1 into minus 1, 1 is your answer. Minus 1 the whole cube, that is the power is in the odd, means you will get minus itself. That's what here it is explained. Okay. Then when a number a is multiplied by itself, the product is called the square of the number. You know that also already explained, a into a, that is a square, that is called as a square number. Okay. Similarly, the square of a number is multiplied by a, then the product is called as a cube, that it is denoted by a cube. You need not say a power of 3 also is correct if you say, or a cube you can say. Like that, a square you can say, or a to the power 2 you can say. Both are correct only. Okay. So cube and square is over. Now let us see some laws of exponents. What are the laws of exponents? We will see. So based on using this laws only, we are going to do the problems. Okay. Now let us move on to the laws of exponents. If a and b are any non-zero numbers and m and n natural numbers, then what are the formulas involved? Let us see. A to the power of m into a to the power of n. The into is the product rule. What is that, children? Product. Since the multiplication symbol is involved, you can say it is a product rule. So a to the power of m into a to the power of n. So that can be written as a to the power of m plus n, because the bases are same. Which is the base here? A is the base. Okay. M and n are the exponent, or it is called as a power. Okay. So the powers should be added. So a to the power of m plus n. Have you all understood, children? The product rule, a power of m into a power of n can be written as a to the power m plus n. Okay. Second one, a power of m divided by a plus n, that is called as a quotient rule. So when divided symbol involve, then the answer will be a to the power m minus n. Okay, the bases are same and the power will be in the negative m minus n. Okay, and third subdivision, a power of m the whole power of m, that is the power rule. You can multiply the power, a to the power of m and the whole power n. Okay, so you can multiply m and n, so your answer will be a to the power of mn. Now fourth subdivision, a into b the whole power of m. So that can be expressed as a power of m into b power of m, because the whole power m denotes for both a as well as b the power denotes. So you can write a to the power of m into b to the power of n. Okay, sorry children, m. Next, fifth one, a divided by a divided by b the whole power of m. So this can be written as a power of m divided by b power of m. And the last one, anything power 0 is nothing but 1. That is, a power of 0 is equal to 1 for a is not equal to 0. So these are some laws, basic laws we are going to use. Okay. For the base number whose unit digits are 0, 1, 5 and 6, the unit digit of a number corresponding to any positive exponent remains unchanged. So positive numbers will not be changed. The unit digit, if it is in 0, 1, 5 and 6. For the base ending with 4, the unit digit 4 for odd power and 6 is for even power. Similarly, for the base ending with 9, the unit digit is 9 for odd power and is 1 for even power. Okay, just it is an explanation. So you will see the next one. The largest power of a variable is an expression is called as a degree. Now you have a degree also to find out the degree in the expression. The largest power, suppose if any equation is given, in that the largest power denotes the degree. Okay, so degree of the particular equation. So if it has more than one variable, then one has to take the sum of the power of variable in each term and take the maximum of all this. So you will be taking the maximum of all this. In case if you have x square into x cube, if you have to add the power, that is x to the power of 2 plus 3. So 2 plus 3 is what? 5. So the degree of the particular expression is now x power of 5. Okay. Now let us move on to the exercise 3.1. First one, fill in the blanks. First question, the exponential form 14 power 9 should be read as. How will you read? Already I taught you 14 power 9. Yes, it is nothing but 14 power 9 you can say. Okay, or 14 to the power 9. You can write in any way. So the answer is 14 power 9. Subdivision 2. Expanded form of p cube q square is dash. So p cube means how many times you have tried to p? 3 times. P square means how many times? 2 times. So you can write P into P into P into Q into Q. Okay. Subdivision 3. When base is 12 and exponent is 17, its exponential form is. So the base is 12. So you can write 12 to the power 17. Okay. Subdivision 4. The value of 14 into 21 0 is dash. Already we have learned in the laws of exponentiation. A to the power of 0 is what? 1. So this answer is also 1. Okay. Now let us move on to the true or false. Say true or false. 2 power 3 into 3 to power 2 is equal to 6 power 5. Let us see it is true or false. Is it true or false, children? Yes, it is false because the 2 power of 3, the bases are not the same. So you can't add the powers. Okay, so it is false. Next, 2 power of 9 into 3 power of 2. So you can write 2 to the power 2 into 3 power 9 into. Is it true or false? This is also false. Why it is false? The bases are different. So you can't bring the powers together. So it is false. Subdivision 3. 3 power of 4 into 3 power of 7 equal to 3 power of 11. Yes, what is the answer, children? Yes, it is true because the base is same. So you can add the powers. So 4 plus 7 you will be getting 11. So 3 to the power of 11. So it is true. So the solution is true. Okay, now let us move on to subdivision 4. 2 power of 0 is equal to 1000 power 0. Is it true or false? Yes, of course it is true. Why it is true, children? Because anything power 0 is 1. So in the left hand side also you will be getting 1 and in the right hand side also you will be getting 1. So the answer is true. Okay. Subdivision 5. 2 power of 3 less than 3 square. So what is 2 power of 3? 8. What is 3 power of 2? 3 3s are 9. 2 power of 3 is 2 into 2 into 2. So 3 times you will be multiplying 2. 8 you are getting. Say of course. So the answer is true because 8 is less than 9. So the solution is true. Okay. Now let us move on to problem number 3. Find the value of the following. Subdivision 1, 2 power of 6. Solution. You have to multiply the 2 power of 6. How many times? 2. 6 times. So the solution is 2 into 2 into 2 into 2 into 2 into 2. So 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64 is your final answer. Okay. Now subdivision 2, 11 square. So solution is you have tried 11 square is equal to 11 into 11. So 11 11s are 121 is your final answer. Okay. Let us move on to subdivision 3. 5 to the power of 4. So solution 5 to the power of 4 can be written as 5 into 5 into 5 into 5. So 5 5s are 25, 25 5s are 125, 125 into 5 will be getting 625. Okay. Subdivision 4. 9 to the power of 3. That is you can say this as 9 cube or 9 to the power of 3. Solution 9 to the power of 3 can be written as 9 into 9 into 9. So 9 9s are 81, 81 9s are 729. Okay. So thank you, children. So today's session is over. Let us continue the balance sum in the next class. Thank you, children. Have a nice day.